Hi, I'll be going over the traverse a graph problem. So for this problem, we're given this implementation of a graph, return all the nodes connected to a particular starting node. Return a set of the names of nodes. For example, here's a graph. So graph equals graph, the graph constructor, and we have several calls to add node where we add A, B, C, D, E, F, C, and several calls to add edge where we do AB, AC, AD, CE, EF, DB. And it looks like this, so we should return self to subgraph A, D, B, C, E, F. So we can see that A is connected to B, C, D, and then since C is also connected to E, we want to return that one. And then E is connected to F, so we want to return that also. So we want to use like a depth first search method, and we want to return every node that connects to A. Okay, so now I'll be going over the final implementation. In terms of Umpire, I haven't really seen this problem before. I have worked with graphs before, but I'm not too familiar with graph problems. So I don't think I really have anything to really match it to before, but I have done some preparation for this problem. So my approach is that I'm going to be using a stack to keep track of the nodes that we have seen, and then or a stack to keep track of the nodes that we haven't seen, and then a set to keep track of the nodes that we have seen. And then I'll just be adding the nodes that are connected to the starting node or starting vertex to the set, and then just making sure that we don't have any duplicates, since graphs are cyclical, and once they get edges created or connections created between two vertices, it can go back to the node, the beginning vertex. So I'll go off and start with a stack. So I'll just have a two visited stack, and then I want to start with the starting vertex, and then I'll be using a set to keep track of the vertices that we have seen. And then while, or this should be to visit, not to visited, so to visit. So while we have nodes that we still haven't seen, I want to store I'm interchangeably using vertex and nodes, but I mean vertices. So I want to store the vertex that we're currently at, that's currently at the top of the stack, in a vertex variable. So I'm going to visit dot pop, and then from here I want to check if vertex not in visited. So if we haven't seen it, then I want to add this vertex to our visited set. So visited.add vertex. And then I want to iterate over the neighboring vertices of the starting node. So for neighbors and self.vertices vertex, so I'm starting with the starting node, but if I want to continue with other nodes, I want to make sure that I iterate over every connected node, and then I just don't want to. I'm using a set to make sure that we don't have any duplicates, but we want to add every connected node from our starting every connected vertice to our starting vertice. So for neighbors in self.vertices vertex, or this should be neighbor. If neighbor not in visited, then we just want to make sure that we check it in our stack. So we add it to the stack, so to visited, append neighbor. Then from here, we just want to return the visited vertices. So I'll go ahead and check it. Let's see. Oh, whoops. I wrote it wrong here. So to visit. Nice, so we got it. So yeah, this just iterates over every vertex in the graph, and then we just want to make sure that we don't add any duplicates because graphs are cyclical. So since we iterate over every vertex and edge, the time complexity ends up being O of the number of vertices plus the number of edges, so O of V plus M, and then in like the worst case scenario, like our to visit stack could have like every like vertex in the graph in the stack, so that could be like O of V or like O of N in that case for space. Okay, so thank you. That's my umpire process for the traverse a graph problem.